Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, my name is Rafi Fadilan. Welcome to my presentation video. I am from Information System student at Universitas Tanjung Indonesia. Today, I'm making this video to fulfill the requirement for final test. The topic I have chosen to discuss is a fascinating and crucial concept in computer architecture called Direct Memory Access, or DMA for short. Before we jump into the technical stuff, let me ask a quick question. Have you ever thought about how you can copy a massive 50 gigabyte game file from a portable hard drive to your laptop, while at the exact same time you are listening to Spotify, having a Discord call, and browsing the internet smoothly without your computer freezing up? Normally, moving that much data should completely exhaust your computer's brain, but it doesn't. The superhero behind this seamless multitasking is a brilliant piece of technology called direct memory access. Today, I'm going to break down exactly what DMA is, why it was invented, and how it completely changed the way our computers handle external devices. Let us dive right into it. To truly appreciate DMA, we first need to look at how things used to work. In any computer system, you generally have three main components. You have the CPU, which is the brain. You have the memory of RAM, which is the workspace, and you have the input-output device, like your keyboard, mouse, or flash drive. Back in the early days, if an external device wanted to send data to the RAM, it used a method called program input-output. Imagine the CPU is highly paid, super smart CEO of a company in program input-output. If a delivery guy brings 1,000 boxes of documents to the office, the CEO literally has to walk to the front door, pick up one box, walk it to the storage room, put it down, and walk back to the door for the next box. The CPU is forced to wait and constantly check if the device is ready. We call this polling. It is incredibly inefficient. The CEO is wasting valuable time carrying boxes instead of calculating complex formulas. Then, engineers realized this was terrible, so they invent interrupt-driven input-output. In this method, the CEO doesn't wait at the door. Instead, the delivery guy rings a bell, called an interrupt. Whenever a box is ready, the CEO pauses their current work, gets the box, puts it in storage, and goes back to work. This is better for small things like a keyboard click, but for a massive file transfer, the bell rings thousands of times per second. The CPU gets interrupted constantly and still physically carries every single piece of data. It is a nightmare for a system performance. This exact problem brings us to direct memory access. The engineers realized, why is the CEO doing manual labor? So they hired an assistant manager. This assistant manager is the DMA controller. It is a dedicated, specialized piece of hardware embedded right on the motherboard. With DMA, the data transfer process completely changes. When you plug in your flash drive to copy that huge game file, the CPU doesn't carry the data anymore. Instead, the CPU calls the DMA controller and says, "Hey DMA, I have a big job. Please read this massive block of data from the USB drive and put it directly into the RAM. Here is the starting address and the total size. I'm going back to my other task. Do not bother me until you are finished. And just like that, the CPU delegates the task. The DMA controller takes over the system bus, which is the data highway, and moves the data directly from the external device. The CPU is completely free to do other things. So, how does this actually happen under the hood? Step 1 is initialization. The CPU writes three crucial pieces of information into the DMA controller's registers. First one is the device address. So the DMA knows where the data is coming from. Second, the starting memory address. So it knows where to put the data. And third, the word count. So it knows how much data to transfer. Step 2 is the bus request. Normally, the CPU acts as the traffic police controlling the system bus. Because the DMA needs to use these buses to move data, it sends a special signal to the CPU called a bus request, asking to borrow the highway. And step 3 is the bus grant. The CPU finish its current tiny instruction, disconnects itself from the buses, and sends back a bus grant signal. This tells the DMA that the highway is all yours. Step 4 is the direct transfer. Now, the DMA is in full control. It transfers the blocks of data directly from the external device straight into the memory. There is absolutely zero CPU involvement during this phase. Finally, step 5 is the interrupt. Once the word count hits 0, meaning all data is successfully transferred, the DMA releases the buses back to the CPU and sends one single interrupt signal. It is basically saying, "Hey boss, the job is done." Instead of thousands of annoying interrupts, the CPU only gets interrupted exactly one time at the very end, because the DMA and the CPU share the exact same system bus. They cannot both use it at the exact same time. They have to share the road to handle this. The DMA operates To handle this, the DMA operates in a few different modes. Number 1 is burst mode. The DMA controller holds onto the bus tightly and transfers the entire block of data all at once. The CPU is locked out of the bus during this time. This is super fast for data transfer, but the CPU might sit idle for a moment. Number 2 is cycle stealing mode. This is the most clever method. The DMA forces the CPU to pause for just one single instruction cycle. It steals a cycle, transfers one word of data, and then gives the bus right back to the CPU. It alternates back and forth this way. The data transfer happens smoothly in the background and we do not feel any lag. Number 3 is transparent mode. This is the sneakiest one. The DMA controller strictly waits until the CPU is doing something that doesn't require the system bus. While the CPU is distracted with internal work, the DMA sneaks in and transfers data. It is highly efficient but complex to design. To wrap things up, understanding how our hardware manages data flow is crucial. Without DMA, modern computing would be impossible. It teaches us a very important principle, which is delegation. By delegating repetitive tasks to specialized hardware, the processor is empowered to focus on executing complex instructions and keeping our systems running smoothly. Alright, that brings me to the end of my presentation. I hope this explanation made the concept of direct memory access clear and understandable. Once again, I am Raffi Fadila from Universitas Teknokrat Indonesia. Thank you for your time and your attention. Stay curious, keep learning, and I will see you next time in the next video. Good. Assalamualaikum warahmatullahi wabarakatuh.